It's always a shock when I'm suddenly live. I don't think I can hear you. Rainer, I guess you're still on mute.
I'm very sorry.
Okay,
Yeah,
cool.
I'm too stupid for streaming. I'm sorry. I just said welcome to have you here on the 16th Rust Meetup. We are very happy to have you here.
Hi also from my side.
Very good. Stefan, I think we get started as every time with a little bit of community news. This is what we announced, so I will share my slides. Give me a sec. Here we are, and now I think the slides are visible. Let's get rid of the logo here. And now we are good. So again, welcome to the 16th Rust Linz Meetup. We are in the middle of a lockdown, but that does not stop the Rust Linz Meetup. Of course not, because we are always virtual, nearly. We had one live meetup and we are really looking forward to next summer. Maybe we'll do another live meetup, but now it's absolutely no change. We are broadcasting from at home and yeah, we are enjoying ourselves at home. Let me quickly change the slideshow here. I messed something up because now it should be better. Yes. Good. So the Rust Linz Meetup is brought to you by our very own coding club, Linz. We are a community of passionate developers located here in Linz, but the Rust Linz Meetup wants to reach everybody on this globe. So from wherever you are very welcome. We are always curious where you are all from. So if you want, use the YouTube chat and let us know from where you are looking. We are interested in which parts of the world of the globe we reach. Today's speakers, let me quickly point out the most important thing. I will do a very quick lightning talk after the community news about Advent of Code. It will be a little bit a short introduction of Advent of Code because I think it's a great opportunity to learn and practice a new language like Rust, for instance. Then we will have our main speakers. The first one is Thorsten Hans. He will talk about WASM, about WebAssembly, Rust, and the use of WebAssembly beyond the browser. And the second speaker is Armin Ronacher. He will speak about SERDI shenanigans, and I'm really looking forward to this one.
Yeah, me too. Absolutely.
Then we have some goodies from our sponsor Microsoft. Microsoft sponsored a little bit of money for us, so we can provide you with free 10 euro Lieferando vouchers. If you live in Austria or Germany, you probably know Lieferando. They will bring pizza or burger or maybe some Indian food or whatever you want to have right to your door. So if you are still hungry and you are thinking of whether you should go into the kitchen, making yourself some dinner or watching the Rust Meetup, we have good news for you. You do not need to make this decision because you can fill out the form, which you see exactly here. And I think, Stefan, you already posted it in the chat, right?
Yeah. So it should be also available in the YouTube chat. I'm going to post it to our Discord folks as well.
Exactly. We don't have an endless amount of vouchers, but we will give them out first come, first serve to those who fill out the form, which is linked here, the fastest. So Lieferando should be available in most larger cities in Austria and Germany. I am really not sure whether it is available in other countries like Switzerland and so on. Simply give it a try. Go to Lieferando and check whether some food is available in your region. Good. So this is the link. Check it in the chat or check it in Discord. By the way, Discord, here is the link. If you haven't joined our Rust Linz Discord server, we invite you to do so. This is the invite link. You can also find it on our website, rust-linz.at. Just click on it, join the community there, and you can also use Discord to ask questions and things like that. Just let's stay in touch using our Discord server. Community news. We want to talk a little bit about what happened since last Rust Meetup. It was Stefan, help me out.
October 29.
29th, exactly. A lot of things have happened, and this time we want to take a look back, just like in a really good sprint meeting where you look back and then you look into the future. So let's take the look back. First, in the end of October, we had just right before the lockdown our last event, which was in person, the Games and LAN, a good old LAN party, which we did at the Grand Garage, one of Europe's largest maker spaces, which is located here in Linz. It was multiple days full of computer games, of board games and paper games and things like that. And it was really great. The organizers had a blast. We had more than 100 attendees, and it was really a great success, and we loved it. Unfortunately, we will have to wait a little bit until we can do other events like that. We had planned some Chaos Computer Camp streaming in winter holidays. Unfortunately, we have to cancel that, but we are looking forward to 2022, and we will see what goes up there. The next thing, I did a workshop for teachers in Austria, teachers of vocational schools, HTLs. And this workshop was about Rust. I offered this workshop through the Pädagogische Hochschule, the university for teachers here in Upper Austria. And I invited teachers to learn about Rust because Rust might be an option, an alternative for teaching C and C++ in vocational schools for computer science. It was a very interesting workshop. I enjoyed it very much. We spent 2 days working on Rust, and I was extremely happy to hear just today that one of the participants immediately took what he learned there, and he did his first lectures on Rust in a vocational school here near Linz, and I was very happy about that. So I love this community spirit where we try to bring our passion about Rust back to the teaching community, so that we can be sure that future programmers will know and love Rust just like we do. The second one is an initiative of you, Stefan. Stefan, do you want to tell us about that?
So actually, it's an initiative by a couple of students at the Johannes Kepler University in Linz. Since last week, there is a Rust course at the Johannes Kepler University. We already had 2 blocks, 8 hours total, where we did everything from ownership and borrowing to trades to error handling, etc. In 3 weeks, we have the next block talking about multi-threading, async await, the entire stuff, and it's been fun so far. So we had about 40 attendees watching each time or attending each time. A couple more that signed up, who I guess I will see at the exam later this year. And the cool thing is this was something that was demanded by the students. So I did this TypeScript course last year. And I was, every time I spoke about TypeScript's type system, I made references and connections to Rust's type system. And I apologized for that might be something that you don't know yet, but Rust is a cool language, learn it. And they said, hey, please teach us Rust. So a couple of students and I went to the institutes, pitched our idea of having a Rust course. And yeah, ever since it's now on the curriculum for everybody inscribed at the local university to choose. And it's been fun so far.
That's really great. I think this makes me a little bit proud. I don't know about you, Stefan, but trying to get the word about Rust out into the community, but also trying to reach the students, reaching students in vocational schools, in university level, and also trying to reach teachers and so on. I think this is really an important part of community work, and I'm very glad and happy that we can be a part of that in the local student and university and school community. That is really great.
Absolutely.
We also did again some workshops. I did a workshop at the API Summit in Germany. Of course, it was also virtual, and there I tried to make Rust more visible in a larger enterprise community who is currently working a lot with programming platforms like, for instance, Python and Java and C#. And I wanted to introduce them to Rust. There was a great interest there, and so we covered the whole area, the the commercial area and the school area and the community area. It was a great month, to make it short.
I have one more story to tell, and this is a little surprise. Also to you, I kept this as a secret until now.
Oh, a secret.
But no, it's not that big of a secret, but it's a nice story. So 2 weeks ago, I was at an in-person conference that was still possible 2 weeks ago. It was in Germany, in Düsseldorf, and it was one from the web community, web development, a lot of design actually, a lot of web fonts, etc. So that was nice. And at the get-together in the evening, a couple of people approached me and told me, hey, I recognize your voice. And usually in this area, I always think, okay, that's because of my web podcast, where they usually only hear my voice. But no, they said, no, am I in some way affiliated with Rust? And I said, oh yes, I am. And then I told them, I'm running this meetup with you, and we do it once a month and have introductory talks. And they are huge fans. So they told me they are huge fans of the Rust Linz meetup. They watch every time. It's something, so especially the videos that are on the official YouTube channel, it's something that helps them navigate through the Rust ecosystem, through the Rust language. And they share bits and pieces, like little snippets from those videos on the internal Slack to discuss that, and they are eager to try it out themselves. And without every speaker that has been at Rust Linz and all the efforts that we do and that you do to give talks, to share your ideas, to share your knowledge with us, it would be super hard for them to navigate around Rust. So kudos to everybody who spoke at Rust Linz. This is from a couple of folks who came to a web design conference and are avid or honest Rust fans, Rust Linz fans, and enjoy everything that we do.
Awesome. Hey, that's so great to hear. Thank you for telling this story. That's a lot of motivation. And also that big thank you in advance go to our today's speakers. We are really looking forward to your talks. Okay, so now we looked into the past. Let's take a look into the future. Of course, as every week, we will have our Coding for Kids workshops tomorrow. Every Friday, we do Coding for Kids, and we have a fully packed program for our kids tomorrow. If you have kids in the age between 8 and 17 and they speak German, feel free to take a look at this URL. Everything is online, everything is free, and we have topics ranging from the very beginners, 8 years, something like this, to semi-professionals who are already in computer science schools. Just take a look, and we would love to see your kids, your nieces, your nephews, whoever in our Coder Dojo Linz Coding Club. The female coders community, our friends at Female Coders Linz, they are also preparing for something which will be a topic in 2 or 3 minutes or so, Advent of Code. They are going to have meetups every day in December, and they are going to work on Advent of Code, coding puzzles every day in December. So if you are interested in visiting a community of female coders, then this is exactly the place where you should take a look at which we should take a look at if you live here in Linz or if you want to participate online. Our next meetup will be on the 16th of December. We already have maybe a great guest speaker, but our speaker portfolio isn't full on the 16th of December. So if you are interested in speaking, if you have an idea, if you want to share something that you found and you think it's cool, it's Rust related and it's really cool, it helped you. So get in contact with us. Don't be shy. We are always beginner friendly. You don't need to be a Rust professional. If you just want to share something that you are passionate about, you are always very welcome. Your talk can be anything between 5 minutes and an hour. Everything is fine. We are very flexible in that area.
Also, if you are not sure, ask us. We are happy to work with you on your idea, do some idea ping pong, etc. So we are very open for that.
Yep.
Absolutely.
Yep, absolutely. Okay, and last but not least, I want to point out the upcoming Rust Summit, where Stefan and I had the honor to help a little bit in putting together the program. And the very important thing for you as the community, we can organize 15% rebate codes, and there are also a limited number of diversity tickets available. So if you are a member of an underrepresented group in the IT tech and you want to go to this Rust Summit, but for whatever reason you don't want to, or you can't afford the price, just let us know. We have a limited amount of diversity tickets which we can give away for free. Rust Summit, 6th and 7th December. It will be an online event because everything else is currently very hard or even impossible. And with that, we are through with the community news. So I would say thank you very much for the community news. And I think the first speaker is, who is that? I think that's me.
I think it's you, yeah.
Yes. Okay. So I will stay here. Stefan, do you want to stay with me here, or will you be behind the stage? What do you think?
I will be behind the stage because
Okay.
I also heard my kids shouting and screaming downstairs,
I
so they might
see.
storm this office in just a
I
minute.
Okay. Okay. Very well. I will see you later on. Okay.
See you later.
Okay. Bye, Stefan, for now. Good, very good. So the first quick lightning talk, only a few minutes, is about Advent of Code. I am passionate about Advent of Code. Let me tell you a little bit about a story, what Advent of Code is and why I am passionate about it. I came across Advent of Code a little bit more than a year ago, and last year we did Advent of Code with our kids and the young coders at the Coder Dojo Linz. And we tried it and we said, hey, you know what? Let's meet and let's do these Advent of Code puzzles. So what is Advent of Code? Advent of Code is a nice little puzzle series that's happening between the 1st of December and December the 25th. This is why it's called Advent of Code. Of course, the coding puzzles are really neatly embedded into stories where you have to help Santa Claus in order to save Christmas. The puzzles start relatively simple, but they become harder and harder as the days go by in December. Luckily, last year at least, the puzzles was not the hardest ones on December 23rd, 24th, and 25th, because that would be a little bit of a coordination problem. But still, in the middle of December, they were pretty tricky sometimes, and we enjoyed it so much. The puzzles are focused on algorithmic challenges and challenges about data structures and things like that. So if this is something that you are into, that's definitely interesting for you. Now, Advent of Code is also a speed coding contest. Every puzzle is published at midnight at Eastern Standard Time. That is UTC -5. I think that's 6 a.m. in the morning here in Europe. And if you want to get on the leaderboard, on the global leaderboard, you have to get up early and you have to be very fast in order to see your name in the leaderboard. I was blown away when I saw how fast some people code. And if speed coding is something that you are passionate about, definitely try it. The good news is, although, if you are not one of the fastest coders in the world, just to give you an impression, Advent of Code is done by more than 150,000 developers each year. I think last year there were 160,000 on the first day, something like this. So if you are not one of the fastest ones in this area, but you are in a community like our coding club or female coders or your school or your community, you can set up private leaderboards and gather stars there. And then you have a private challenge a little bit. And yeah, you are also learning things. I think that it's a great practice, a great possibility to practice a new programming language like Rust, because Advent of Code is completely language agnostic. You can start with Rust, continue with Go, go on with C#, move to Python, and even do some things with, I don't know, Wolfram Alpha or Scratch or Excel. It doesn't matter. And of course, Advent of Code is a lot of fun. So let me quickly describe you in just a few minutes how Advent of Code works. This is your goal. This picture here is your goal, because this is how your Advent of Code event page should look like at the end of the year. Of course, I hope at least we'll get a new ASCII art for this year, but this is my page from last year. Last year I earned all 50 stars. Now, at the beginning, you start on a blank slate. So you will not see all the puzzles on December the 1st, but you will only see the puzzle of the 1st of December. And then you can tackle the puzzle of the day, or if you are curious, you can now also go back in the previous years and take a look at those puzzles and do them as a kind of preparation. If you don't have time on a certain day, you can always go back the days that you haven't taken a look at. So that's easy. That should be fine. Now, all the puzzles are embedded in a kind of story about Santa Claus. I already mentioned that. But from a technical perspective, it's super interesting that all the puzzles come with some examples. And in this case, I took a very simple entry-level puzzle from, I think it's 2019, where you just have to take a bunch of numbers. You have to divide them by 3, round it down, and subtract 2 to get the result. And here you see in the yellow rectangle, you see the examples that I meant with the solutions. So what you can do on each day, you can take these examples and do test-driven development. So you can write the unit tests first and then write the algorithm. So let me quickly show you how that could look like in an example that I have done. Here you see, whoops, sorry, I forgot to start my zooming tool. Now it should work. Here you see this beautiful function. This is the difficult function that I had to write. And then you can use, for instance, unit testing. This is how I typically do it. I create a test module here in Rust, and then I add the samples here in my unit test. So you can really do test-driven development. That works pretty well and is also nice for people who start coding. Now then, it's getting real because you get your personal puzzle input. Advent of Code does not have a single input, a real-world input for everybody, but you get your personal input. You download it, and it looks something like, for instance, this one here. The puzzle input is always kind of a text input. So here you can practice things like file handling. You have to read the file. You can practice things like regular expressions. For instance, working with matches or capture groups. If you don't know what capture groups is, Adword of Code is a great way to find out. Splitting strings into spans, doing some alloc-free algorithms with Rust. That's a lot of fun. The Advent of Code guys say you shouldn't download the input via HTTP requests and do that pretty frequently because that might put a stress on the servers. So you are encouraged to download the file by copy and pasting it, putting it into a local file, and then do all the development locally. If you really download the demo data via HTTP automatically, please do some caching in any way to not overstress the servers. Now, then you have to go on and process this input properly. And nearly every time it is about a kind of iterator or generator. So this is a great thing. If you are new to Rust, you can practice iterators, building custom iterators. For instance, recently I took a look at one of the examples last year, and I wanted to find out what about this yield macro. If you have never seen it, Google it. I was looking for a kind of yield operator in Rust. There is no yield operator in Rust yet. You probably know that, but there are crates about it. And I used an Advent of Code puzzle to dive into that matter because I simply wanted to play with it. And Advent of Code is a great place to learn about iterators and generators. And then at the end, you come up with an answer. It's typically a number or a text. You type it in, and hopefully you'll get your first star. But that's not all. You're not done yet, because then the second puzzle appears. Every day consists of 2 puzzles. You have to earn a second star. So you get a slightly more difficult version of the original puzzle. And that is a great possibility to go back to change your unit tests or add new unit tests. You go back into coding, and especially important, you practice refactoring. You have an existing algorithm, and now you have to change it, to generalize it, to introduce abstractions, so you can use common code for both problems and make the different things really different. So I personally think this is a great way of learning and practicing refactoring in a language that you know or that you are currently learning, and that will lead you to, hopefully, 2 stars. And that is the goal of every day. And at the end, on December the 25th, you hopefully have 50 stars. Let me tell you a few tips that I have learned, some of them the hard way, last year, for instance. Think about what you want to get out of Adword of Code. Maybe you are into speed coding. If you are into speed coding, don't forget your alarm clock. You have to get up early, and quick and dirty coding is perfectly fine. Maybe if you really want to go into speed coding, you shouldn't take a new language. You should take a language that you really know, really very good, and you try to get the correct result as fast as possible. But you can also have a different mindset. You can say, I want to practice a new language. And then maybe you focus more on quality and idiomatic coding. But don't underestimate the additional effort if you try to do it with a different language that you don't already know, because at a certain point in December, the challenges will be rather tricky. So maybe you want to mix things and go back to the new programming language a few days later when there is time. It is a good idea to join a group, because otherwise you try to do it, but you never find the time. If you have a fixed appointment in a group, that's way easier to do, because then every day you meet and you have fun and maybe have a pizza or whatever and try to solve the puzzle together. Yeah, and of course, maybe you use the old versions to come up with a kind of project or workspace structure. Think about how you want to structure your work with the unit tests and so on, so you do not need to build it on December the 1st, or you use the first puzzles, which are pretty simple on the first few days, to get into Adword of Code. Speaking of, the last one, sorry. If you really want to have 50 stars on the December 25th, hey, prepare your family early that you are going to spend some time in front of the computer on December the 24th and the 25th, because maybe it's good to give them a heads up if you are planning to do that one, okay? Speaking about communities, what are we going to do with Adword of Code and communities in Linz? We are going to do, again, Adword of Code with the kids and the young coders at Adword of Code at the Coder Dojo Linz. We will meet daily and solve the puzzles together. And last year, by the way, 2 young coders who are just in school, one of them was 13-year-old, managed to get 50 stars on December 25th. So they really made the challenge. That was great. If you are interested, if you want to help us, if you want to be a mentor for young coders, maybe with Rust, that's perfectly fine. Get in touch with me. We would be very happy to greet you. And now I would like to bring up our friend Fred from Vienna Rust Meetup. Hi, Fred. Can you hear us?
Yes. Hi, Heiner. Thank you for having me.
Awesome. Fred contacted me and he asked me whether he can share a meetup that they will do in Vienna in relation to Adword of Code. And I immediately invited Fred to come to us today at the end of this lightning talk. And maybe you can tell us a little bit what you are going to do in terms of Adword of Code and Rust in December 2021.
All right. So thank you again for having me. And the first thing I want to talk about is what is mob programming. Because this advent of the rustic mob is about mainly mob programming. So mob programming is an approach to software development where the team gets together to work on a task or the project at the same time and in the same place. So the advantages of that is that it improves team collaboration and knowledge sharing, and it also kind of reduces distractions and interruptions. So how it works is that each person in the group gets their turn to either be at the keyboard, this is called the driver, to be the instructor who instructs the driver on what to do, this is called the navigator, or follow along and support the navigator when needed. This is called being a member of the mob or a mobber. So each person spends a few minutes in the role, and this sequence rotates through the group until the task is done. So nowadays, due to isolation and COVID and so on, mob programming is primarily done via Zoom, screen sharing, and online IDEs. So I want to talk a bit about the mob programming on open source software meetup group. So this is a meetup group with about 200 plus members now. And the main focus of the group is to bring people together to do mob programming on open source software, like maybe fixing a bug or adding a new feature. Each session is about 3 hours long and usually concludes with a pull request to the open source project. These happen quite often, usually on once a week or so on Wednesdays. And then what about the advent of the Rustic Mob event? So that event is also a meetup event as part of the Mob Programming on Open Source Software meetup group. So this event is organized by Harald, Kushig, and I, and it is about working on the advent of code problems using Rust and in a mob programming setting. We think that it will be a really good way to learn about mob programming, and if you want to learn Rust, then to learn Rust, and to also improve problem-solving skills. That being said, you don't have to be new to any of these three things to join. But also, if you are new and if you are a beginning, you're very welcome to join. So our first event will be this coming Wednesday, the 1st of December. We will start, obviously, with the first problems from Advent of Code. So if you're interested, please join us. We welcome everybody. So yeah, that's it.
Thank you, Fred. Thank you very much. So if you want to do Advent of Code, but you are tired of coding alone, that I think is a great opportunity. Now you have an opportunity to work on it for kids and with kids in the Coder Dojo. And if you are a professional developer and you want to get in touch with other professional developers learning Rust or who are passionate about Rust, then the meetup that Fred just told us about is a great way to do that. For all who are interested, but you don't find it on the internet, I will post my slides that I have shown you now here in the YouTube chat in a second. And there we have a link to the meetup of Fred. So you do not need to start Googling immediately. You will find the link in the YouTube chat. And of course, I will also paste the link in the Discord server. Fred, thank you very much for visiting us, and we wish you a nice December and a lot of fun with the Advent of Code puzzles.
Thank you very much, Heine. The same to you. Thank you.
Thank you very much. Thank you. Okay, so that was a quick lightning talk, an introduction to Advent of Code, and I hope you found it interesting. I hope it was an interesting visit into this world of code puzzles. And now to something completely different, because now I want to bring up the first main speaker of today, Torsten. Let's check whether Torsten, you are here. Very good.
Hi, thanks for having me.
Yeah, we are very happy to have you here. We are looking forward to your talk. I don't know if you know, we already had in the past talks about Crustlet and Wasm. It was at a very early stage. We had some guys from Microsoft here talking about this topic, and we are really looking forward to you telling us a little bit about what the status of Crustlet is, what it really is, what Crustlet has to do with WebAssembly, and whether it is fully production ready, which I think it is not because it's a preview. But yeah, I have no idea. We are looking forward to your talk. Okay. Torsten, I think technology-wise, everything should be fine. Do you want to share the screen immediately, or will you share the screen later on?
Yes, I will bring on my screen. Just give me a sec.
Okay. Yeah, no problem. We are perfectly in time. I think we announced 6 p.m., so we are just a few minutes behind the schedule, but that is perfectly fine. Is that the correct one?
Yes, that's the correct one.
Thank you very much. We are glad to have you. And Torsten, the stage is yours.
Yeah, thank you, Rainer. So, as Rainer already mentioned, today I will give you a quick introduction into Crustlet, what it is, and why you should care about it. So first of all, quick introduction to myself. My name is Torsten. I work as a consultant in Germany with ThinkTexture. My main focus is cloud native and Kubernetes. And if I speak about public cloud in the context of cloud native, it's almost always Azure because I have a deep or long history with Microsoft. And another key focus area of mine is Terraform, so infrastructure as code. I've been diving into Rust, let's say a couple of months ago. I really enjoy it. It's really refreshing, to look into different languages. And at some point, I stumbled upon Crustlet, and that's why I invested a lot of time in the last weeks or so to dive deeper and to see what's possible and what's not possible yet. So if you have any questions about those topics, don't hesitate, just ask. So either shoot me a mail or reach out on Twitter. I'm happy to help. All right. So basically, I've divided the talk in 3 small main sections. So first of all, we do a quick introduction, why WebAssembly beyond the browser. Then we will look at Crustlet, what it is, and how you can get it, how you can get up to speed. And then we will take some very, very basic WebAssembly workloads and run them in a Kubernetes cluster. Okay, with that said, let's jump into the topic. So WebAssembly obviously was in the browser at the first place. So we were able to compile against WebAssembly, take a WASM module, load it in the browser, and execute code that was not intentionally written for the browser as a platform. But there were movements to bring WebAssembly to other platforms, so going beyond the browser. And back in 2019, I guess there was the idea of coming up with a system interface to unify how our code compiled against WebAssembly or against that new interface called the WebAssembly System Interface, or short WASI, will interact with the underlying operating systems. Because the idea is, I think it was Java back in the days that came up with that promise: write runs and run everywhere. And that promise still has to be fulfilled somehow. And my guess is that WebAssembly with WASI, with WebAssembly System Interface, is able to achieve that. So we have WASI as the platform that we can compile to, and then WASI takes care about all the underlying operating system specificas, like how files are handled, how network interaction is done, and so on and so forth. So that's kind of the underlying idea of going beyond the browser with WebAssembly. And obviously there are multiple WASI compliant runtimes available. Wasmtime is perhaps the most popular or the most well-known one. But there's also Wasmer, which is actually written in Rust, which implements all the WASI specification. So if we break it down, okay, why should I consider compiling my Rust application against WebAssembly as a platform and then running that one on the server or in the cloud? Well, obviously it's portability. I mean, if we compile against WASI instead of compiling against Darwin, Linux, or Windows, for example, we end up with having a single binary, right, that we can take, throw it over the wall and get it executed by a WASI compliant runtime, no matter which one it is and no matter who's operating that one. So is it in, perhaps the cloud vendor is in charge of, ensuring or operating or taking care about the runtime being as efficient as possible. So, or it is me. So there are a bunch of, I would say, CLIs or applications already leveraging Wasmtime or WASI as its runtime. So we download the actual application as a WASM module, and we are using Wasmtime to invoke it. So portability is one of the main why we should care about WebAssembly beyond the browser, and the other one is security. And I've taken, to explain portability and security, I've taken some of the pictures from one of the first blog posts or articles written about WASI. So the link is in the slides, and I will share the slides obviously after the talk. So Portability, as I already said, we compile against the WASM32 WASI platform, and then we will end up with having a WASM module, which we can then run by leveraging Runtime, for example, on Linux, on Windows, or on macOS. So yeah, for us, it's easier. We just have that one distributable as an application developer that we must provide. And we have the guarantee, right, that the underlying runtime takes care about interacting with the operating system. The more interesting aspect, or the more interesting why, is obviously security, right? So if we take a look at how applications get executed traditionally, is we have something. So we have the kernel, right, the operating system with all its APIs, and then we have the so-called user mod. So that's where I execute applications, and those applications typically interact with the operating system APIs by issuing system calls in behalf of my user account. So what typically happens is an application say, hey, as written on that picture here, hey, I got invoked, or I'm running in the user mode of Alice, and can you please open that file, right, or that directory in that case? And the underlying operating system checks, okay, does Alice have the permission to open that directory? And if so, it hands over, or it allows the application to read the directory or the files in that directory. That's how it works today, right? So you can think of if you're familiar with open authentication too, for example. In open authentication, we have a user and we have a client, so the application, right, that we are actually using. And in the traditional mode, how applications are executed on an operating system, we are lacking control over the application somehow. So the application always talks with the operating system in behalf of the user. So a malicious application could ask the operating system, hey, can you open that Bitcoin wallet for me and provide the path to that Bitcoin wallet on the logical disk or on the physical disk? The operating system checks if the user Bob has permission to that file. Yes, he has. So it opens up it allows the application to open that file. And as you can see, now the malicious application or risky app asks for a network connection, which, well, obviously, if Bob has that permission to talk over TCP, for example, then the application could send all the contents of the wallet to a remote server or so. And that's a problem that we were facing today, right? Especially if we have applications becoming complexer and complexer, and we're bringing in third-party dependencies, which typically or recently led to a way more vibrant discussion about DevSecOps, right? About scanning third-party dependencies and to see what actually is part of an application. But with WASI, so with the WebAssembly system interface, what we can do there is, so a WebAssembly module is always sandboxed, right? So the sandbox itself, we can let's say whitelist certain APIs. So for example, if we come back to the sample of doing some kind of file access, well, that may be allowed. So maybe we say, okay, hey, risky app, you're able to read, let's say, the user folder and all its content. Okay, so the operating system will allow the application to read the files. However, if we not allow that risky app to do any kind of network communication, then the WebAssembly runtime, so WASI time in that case, won't allow that particular application to do that, to access the underlying network infrastructure, right? Where on the other side, for example, the trusted app that may get granted the permission to take or to communicate via network, but the app doesn't need any kind of local file system interaction, so it may not have the permission to read the file. So basically, WebAssembly and WASI would allow us to define permissions based on the actual application, which is a good thing, which we were missing in in a desktop application space, let's say it that way, for a long time. So that's why I think security is one of the most important aspects what WebAssembly and especially WASI brings to the table. Okay, with that, so a little bit about the background and why, let's dive into Crustlet. Okay, so Crustlet, I mean, Rainer said that there was already a talk about Crustlet, and I am sure that, for example, Ryan was here talking about Crustlet. So Crustlet is, as the name implies, it's written in Rust, right? It's basically a marriage of two things. So we have access to a WASI compliant runtime. By default, it is Wasm-Time. And we have an implementation of one of the most prominent components of a Kubernetes environment, which is the kubelet. So in Kubernetes, the kubelet is responsible for running workloads. So basically, if we as a developers, let's say we interact with the Kubernetes cluster, and we say, hey, Kubernetes, please run that application, right? So we persist something in Kubernetes API server, so in etcd. And what Kubernetes does, it fires an event that pod is the atomic unit of work in Kubernetes has been requested. And then there is a scheduler. So the scheduler is a component in Kubernetes, which is responsible for, actually scheduling workloads to virtual machines or to nodes, to worker nodes in the cluster. And the kubelet gets a notification or reacts on that, on the schedule, and says, okay, I am aware of what I should do. So it pulls down a container image, if we speak about containers, and it runs that using containerd as a runtime. And Crustlet, with Crustlet, we get rid of containerd because we don't need containers, because we use a WebAssembly and Wasm-Time, so the WASI compliant runtime, as an isolation layer, as an application platform, right? So still, Crustlet gets the request to execute a workload. Then it somehow, we will see in a minute how, it somehow pulls that WASM module and executes it using Wasm-Time. So that's how those two components work together in Crustlet. And on top of that, obviously, Crustlet behaves like any other, let's say, node in a Kubernetes cluster. So we can ask for logs that a workload produces. We can take a look at what makes that workload actually happen. So we can get information about environment variables, stuff like that. And we can, collect logs from the kubelet so that we can see how the overall utilization is, how the kubelet reacts to certain things like scaling and bringing on new kubelet worker nodes. Yeah, Crustlet has a flexible provider module. So Wasm-Time, as I said, is the default runtime for WebAssembly workloads, but that can be changed. So you could obviously switch to a different WebAssembly runtime. A bit more, to when you do hands-on. Basically, Crustlet is just a binary, right? It's a binary that you can run on any kind of machine, and it brings in that compute power from that particular machine into your Kubernetes cluster, right? So we can install Crustlet in a wide variety of Kubernetes distributions. It starts small with Kint, so Kubernetes and Docker. That's what I use locally for testing or working with Kubernetes in the inner loop. Or if you grow, or if your requirements grow, you can obviously install Crustlet in regular Kubernetes clusters, or if you use a managed Kubernetes environment, for example, AKS is Azure Kubernetes Service, or the AWS or Google Compute Cloud competitors, then you can install or bring in Crustlet there too. So the question is, why Azure, right? Why should you take a look at Azure when you're focusing or diving into Crustlet? So obviously, Crustlet is an open source project, but if you take a look at the actual contributor who's maintaining the project, those are mostly full-time employees that work at Microsoft. So Microsoft has a huge interest in making Crustlet successful, because that would allow them to drive the utilization of compute resources, right? Because WASM, the WASM runtime and WebAssembly itself, I mean, we don't need any kind of Docker host, right, to run applications isolated from each other. There is the WebAssembly runtime, which is, from my point of view, so my experience is what I tested on the environments I got my hands on. It looks like it is more efficient compared to containers. And what always stands for, or for what Microsoft always stands for, is integration, right? So adding things or integrating with existing services is always top on mind when at Microsoft. So, and the same applies about how to get your hands on Crustlet. I mean, getting a Kubernetes cluster, a full-blown Kubernetes cluster in Azure takes like 5 minutes, and that's the competition, right? The competition is always between those public cloud vendors who is able to reduce the time till you can access your Kubernetes cluster. And when it comes to Crustlet, it's a one-liner. Right, you need an extension, which is currently in preview, that you can install locally if you work with Azure CLI, and then you can just extend any existing Kubernetes cluster and bring in Crustlet nodes to run your WebAssembly workloads. And another interesting thing which Microsoft gives you out of the box is the support for the WebAssembly gateway interface. So the gateway interface is basically an interface which allows you to route network calls. So for example, you can say, okay, I want something in my cluster to react to a GET request on the route /hello, and then you can point to a WebAssembly module which is responsible for dealing with that GET request. And on the other hand, you may have a post request to another route, and then you can point to a different Rust or WebAssembly module. And this allows us to, do microservices, let's say it that way, but on a way more fine granular level, right? We can, for example, say, well, this action, I can use Rust to get that up and running in minutes. And perhaps for another route, Go or C# is way more efficient to get that work done. So I can focus more on how can I achieve that that workload efficiently. I just have to compile it against WASM32 WASI. Okay, enough of slides. Let's quickly take a look at Crustlet in Azure. So let me jump over to the browser. So I've already provisioned an Kubernetes cluster. There is no Crustlet integration yet. And I've also provisioned a container registry. We will take a look at that in a second. So if we dive into the Kubernetes cluster, we can take a look at the node pools. And we see there's a regular node pool, which is running Linux. So let me quickly go to the nodes. That should be easier. So we see there is a regular Ubuntu 18.04 running, and it's able to run containers using containerd as a runtime. Okay, so what I've done, let me switch over to the terminal. Is the font size big enough? If not, just reach out in the comments, then I can bump it even more. Okay, and if you're wondering which terminal I use, so I'm always interested in terminals. I use Warp. If you know Warp, Warp is a terminal written in Rust, and I have 5 invitations left, so it's currently a closed preview. If you want one, please reach out on Twitter. So just mention @Linz, and we will. We will raffle the 5 invitations. So someone will get access to that one, and everyone who gets access can again invite 5 others. So maybe we can spread Warp a little bit more, because I think it's a super efficient terminal. It yet has to catch up with iTerm, but yeah, let's go back to topic. Okay, so I have kubectl installed on my machine. kubectl, but I'm a lazy guy, so I have an alias k, which is kubectl. So don't so bear with me. So I have different clusters I'm able to talk to. Let me quickly config get context, verify if I'm looking. Oops. Okay, config get context. There's an S missing. Yes, I'm looking at the AKS one. So you see over here. Let me quickly ask for the nodes. So Kubernetes, give me all the nodes, and we should see the same as we previously saw in the portal. Yes, there's one. So I've installed the extension to bring in Crustlet, right? So I can easily do AZ AKS node pool add, and let me bring that one from the history, because that's easier than remembering the name of my resource group. So what I basically can say, hey, there is an existing Kubernetes cluster with that name and that resource group. Please create a new node pool. A node pool is like a logical construct. So technically, it's a virtual machine scale set. And I say, in that scale set, please provision 1 VM. And hey, please use WASI as the workload runtime. Okay, so it's a one-liner. Let's give it a shot. And yeah, we see, okay, that's part of the preview extension that you have installed. And in a couple of minutes, we should be good to go. But let's keep that running over here, and let's move on to the Crustlet side. So this is the official Crustlet website, so crustlet.dev. And maybe, I don't know when the meetup was, when the guys from the team were talking about Crustlet. So we saw a lot of improvement when it comes to onboard Crustlet, so to bring Crustlet into your environment. Obviously, there was Crustlet had that momentum when they released the first major version, and then there was Ignite when Microsoft announced a preview for Crustlet and AKS. So if it has been a while since you double-checked the guides, give it a shot. They improved massively in the last weeks or so. Okay, so I think it should be up and running. I don't know, it takes a while. I'm not good in waiting at something. So let's move on to Visual Studio Code. We can revisit that in a second. So the question is, how can we get a WASM module? Obviously, we can use Rust up to bring in WASM 32 WASI as a target, and then we can compile against that one. So I have 2 really, really fundamental samples, right? So it's nothing fancy here, right? We have a WASM workload, which is doing nothing than, you know, just in an endless loop printing information to to the standard output, right? So nothing fancy here. So I can compile that one, obviously, against the WASM platform. Let me go to Hello Crustlet, and let's say cargo build, and let's say I want to do the release build, and I have to target for our desired platform. All right, so that one is built. Obviously, I didn't do any change, so I can run that using WASM time run target. Then there is this one, there's this one, and there's my WASM module. And as you can see, every 750 milliseconds, hello crustlet message will be printed to the standard output. So having a WASM module, we can leverage every OCI distribution spec compliant container registry. So basically every Docker registry that's able to deal with OCI, Open Container Initiative artifacts. Because we can take a WASM module and just push it to that registry. So we have a secure and obviously on most situations, a trusted distribution channel, which is really important. So I have previously published, let me go to the resource group, a container registry. So the question is, how can we get the WASM module as an OCI compliant artifact to our ACR, so our Azure Container Registry? And there is, as always, there's a small tool that's called WASM2OCI, which is just a CLI that we can use. Let me switch back to Visual Studio Code. Let me go into target release and target release, target WASM 32 release. So here's my WASM module, right? So hello crustlet WASM. So I can use OCI to WASM. Wasn't that in my path? No, WASM to OCI, obviously. Push, and then I can say hello crustlet.wasm, and I just have to provide a name how that artifact should be called or should be persisted in my Azure Container Registry. And Azure Container Registry has a requirement that you have to fully qualify your artifact. So it's always your individual name of your ACR instance AzureCR.io, and then you can obviously specify the name of that artifact or of the repository. Let's say hello rust dash, and we give it a tag of 0.0.1. Hopefully the token is still valid, and yes, it pushed it, so we can see we should be able to find our WASM module, and there's hello rust Linz in the container registry. And from there, Crustlet is able to pull that workload. So how can that be pulled? Because ACR obviously requires some kind of authentication. And as of today, we have to specify credentials for that container registry in Kubernetes as a secret, right? It's so-called image pull secret that we can then list on the actual pod, so on the vehicle that we use to run our workload. Azure does a great job in integrating things, as I mentioned earlier, right? So normally what you can do when you rely on containers, you can just, say, hey, this AKS, so my Kubernetes cluster, can leverage so-called managed service identity with role-based access control to pull, so to download things from that container registry. That does not work with Crustlet yet. Hopefully yet. So we have to specify, we have to persist a Kubernetes, a special kind of Kubernetes secret in the cluster that that Crustlet is able to take into consideration in order to pull that WebAssembly module from Azure Container Registry. Okay, so we have a workload in our container registry. Let's jump back to the terminal, and there we go. We onboarding a Crustlet in AKS worked. So we got a not so good looking table output over here because there's so many metadata involved. So let's dive into the cluster itself. Let's say kubectl get nodes. And you see right now I have a Wasm WASI pool with a VM there running in version 1.0.0 alpha 1. And if we dive into that one, so let's say kubectl describe node, like that one. Let's go scroll a little bit up there. We see a bunch of labels and taints being assigned to that particular node. And in contrast to regular container-based nodes, let's say it that way, we see that the architecture is set to WASM 32 WAGI. This is specific, or this is true for AKS. If we bring in Crustlet to other Kubernetes distributions, as we will do in a second, there will be WASM 32 WASI. So this is a value add from Azure again, that we get the WebAssembly gateway interface on top for free, right? So that we can leverage, or we can run workloads as responder to HTTP calls and stuff like that. So that was the good story about the actual state of the preview. The bad story is I reached out to Rainer yesterday and said, okay, I'm not able to run the simplest ever WASM module currently in AKS with Crustlet. So unfortunately, there seems to be some kind of misconfiguration. Maybe it's due to my Kubernetes cluster, but I spun up another one. So I was not able to get it up and running in AKS. However, I have other Kubernetes clusters, right? And it's not about Azure today. It's about Crustlet and Kubernetes. So let's say config get context and texts. And let's quickly switch over to kubectl config use context kind. So I have a kind cluster running locally in my, in my Docker desktop environment. So I have Docker running locally. And if I do kubectl get nodes right now, you see I have just running a control plane. There's and a master, obviously. So there's nothing installed yet. There's no Crustlet. And what I have is I have a Crustlet folder. And I've downloaded, according to the official documentation, I've downloaded the Crustlet binary that I can use to bring in my compute power so that WebAssembly workloads got executed on my machine, right? So what I've done, I've also downloaded the bootstrap script, which is a shell script that takes care about, building a Crustlet configuration for your needs. So that's estimates the current Kubernetes, the kubectl context, and based on that, it creates, let's say, config file which is located in config-bootstrap.conf. And as you can see, there is a certificate, for doing TLS-based authentication between the Crustlet and the Kubernetes cluster. And that's everything over here is obviously tied to the Kind cluster I am looking at right now. So I've downloaded the Crustlet binary. So that's Crustlet Vazi. And upon bootstrap, I have to provide that config. So again, download Crustlet, the binary, download the bootstrap file, run the bootstrap file, and then we use that output, so the generated bootstrap.conf, in combination with the binary to bring in our own Vazi node into the Kubernetes cluster. Let's do that. And there we go. Yeah, there is some workloads that are obviously container-based, so that is not able to be executed in Crustlet. So let's go to another terminal instance, and let's again do a kubectl get nodes. And as you can see, there's that's the host name of my machine right now being available as a node. So with that, let's bring some actual workloads to that cluster. So before I forget, I mentioned about how to make Crustlet able to pull Docker or to pull WASM modules from the Docker registry, so from the private Docker registry, right? So I have to provide credentials, and I have stored them over here. So that's a regular Kubernetes secret, cut ACR pull creds. So that's just a base64 encoded representation of that Docker config JSON, which is basically telling, okay, there is an ACR instance running at my individual name.azure.cr.io. Use that username and use that password in order to pull down OCI compliant artifacts, no matter if it is a Docker image or no matter if it is a WebAssembly module, right? So let's bring that, let's install that in double quotes in Kubernetes by saying kubectl. I should just write K, right? kubectl apply -f. That's called ACR pull creds. Okay, and with that, you see secret ACR created. So let's verify that one. K get secret. And you see, okay, that's in the default namespace because I didn't specify any kind of namespace, and then all my queries run to the default namespace in Kubernetes. All right, so back to VS Code. We have our workload over here. I have a Kubernetes folder because I want to structure, the deployment manifest and stuff like that a little bit. So let me quickly bring in pod. So pod is the smallest unit of work in Kubernetes that we use to run workloads. Hello Crustlet was that. And then we specify our image that was WASM beyond the browser.azure. Let me copy that one. So if I do a mistake over here in the name, then demogods will not be good to me. Okay, we have to specify some resources. That's totally optional, but definitely one of the most important things to do in Kubernetes. So let's say our app needs memory because it's super complex, right? It needs 16 megabytes of RAM, and it needs, let's say, what have I had? It needs 5 milli-CPUs, or let's say 10, be on the safe side. And if our WASM module takes more than, let's say, 32 megabytes of RAM, or it takes 25 milli-CPUs, then something is not right? And then Kubernetes should kill that thing and start it up again. So important not to forget, I have to, we don't need ports. We need, obviously, on level of containers, we need image pull secret secrets, and the name of that one was specified as ACR. So that is normally, that's all you have to do to run a workload in Kubernetes. But we have multiple nodes, right? There was that one node which is able to run containers, and there's our crustlet, and we have to target crustlet. And if you remember, we looked at AKS over there. We looked at AKS and scroll up, and we have labels and we have tains over here. And let's revisit those tains in our this thing, kubectl get nodes, and let's grab the host name and let's say kubectl okay describe. I think I have to add, describe node. And now, not running in Azure, you see we have WASM32 WASI. We don't have WAGI. We don't have the network gateway interface. Okay, so we can add so-called tolerations to our workloads that say, hey, please target a specific thing. So in our case, we want to target nodes with WASM32 WASI. Okay, let's save that one. That's everything we need to specify in order to target that workload always and only to nodes running crustlet. Okay, let's go there. Let's go in the other folder that was CD001 hello crustlet. Let's clean up the thing and let's say kubectl apply from file, and that is port. Oh no, it's Kubernetes port.yaml. Error validating, did a mistake. Resources, did a mistake. It is request S. That's plural. Oh, and I did another mistake. Okay, so now we go. There we go. CPU. Okay, there we go. So let's double check. kubectl get PO. So give me all the pods. And we see, hey, this one is already running. And let's give out some more information. And we see it's running on my machine. So if I go back to this one, so where the crustlet is running, I see, okay, there's no output yet. So that looks pretty good. Let me get some logs, kubectl logs, and I can provide the name of the pod, which is hello crustlet. And as you can see, there have been generated a bunch of logs already. So that is the most simple or the simplest workload we can run with WebAssembly in Kubernetes. But typically, applications need to interact with things, right? They need to interact, for example, with the file system. Again, pretty similar, very easy application. It's just taking a configurable target, which is a folder, right? And then every now and then, so basically every 2 seconds, it's writing a file to that particular folder. And the file is just a random, it's just the iteration. So in int32 that gets increased every time, and then I'm writing instant now. So milliseconds since, I don't know what it is, first of blah, 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 90 something to that file. So that doesn't matter. It's more the fact of, interacting with the underlying operating system API. And this has to go through WASI. Let's quickly go up into that folder, CD002. I have to hurry up a little bit. And let's say, clean up that thing, wasm time run /target /wasm WASI target, now release hello WASI. And let's, that was right. So let's provide --env, let's say target equals, let's say /users /Torsten/desktop. Okay, so I set the target, that environment variable for the particular WASM module to that folder. So the application should write files onto my desktop, right? Let's invoke that one. Oh, it's --e. There we go, and we got panic because WASI protects our system resource from being accessed by that WASM module. What we typically do with WASM time is we have to provide it access to that folder by specifying it using the dir argument. So let's say users Torsten, and let's use downloads. Let's change that. It's not desktop, it's downloads. With that, the apps keep running, and it will. Let's kill that thing, and let's do a list all files of my downloads folder. And as you can see, there is the file there are 3 files already being created. So basically, I have to bring in or to allow that module access to certain file locations, to certain operating system APIs that I want that application to leverage, right? And this is a concept we can super easily adopt in Kubernetes. Because if we take a look at the pod spec, let me quickly bring up just a template. And what we can do, we can take something that's called volumes, right? So we can bring in persistent storage. For example, let's say, I don't know, sample. And a sample can be, over there, that can be an Azure disk, Azure blob storage files, you name it, right? AWS Elastic Blob Store, whatever. That could be a iSCSI storage available in that network. Or in our case, if we run in Kint, so let me bring in the actual manifest. So what I do over here, I specify a pod called hello WASI and reference it again from the same ACR. I set the target, so the target environment variable to mount/data. And mount/data comes from something that's called volume. And the volume will allow that particular WASM module to have access to the out folder sitting here in VS Code, so we can easily verify if everything works as expected. And again, we have those tolerations to ensure that our workload will be executed on Crustlet instead of the regular Kubernetes nodes. So let's go to cd Kubernetes, where there's the pod file, and let's say, hey kube, hi, that thing, and that's created, and you see logs popping up over here. And we should also see, if we say kubectl to wide, to give me all the information, and you see this one is running since 30 seconds ago, and it's also running on my Crustlet machine. Okay, so we are able to integrate seamlessly and to fine granularly control what the WASM modules are able to do in Kubernetes by leveraging first-class, or first-class citizens like storages or volume mounts. Okay, with that, let me quickly switch back to the slides, because we have to catch up with the slides a bit. As I said, okay, in AKS, the actual combination of AKS and Crustlet did not work for me, and I tested it yesterday, I tested it today, and then I decided, okay, let's go with Kint, because otherwise we could also have had a look at the WebAssembly gateway interface to, route HTTP requests to WASM modules, which is typically what I do in my day-to-day life. I deal with web APIs, and yeah, so obviously what you have to do, you need access to some kind of OCI distribution spec compliant container registry. I use Azure Container Registry all the time. I'm loving it. I'm loving the experience they provide. And you have to add that platform to your toolchain. And then you have to build against WASM32 WASI. Yeah, we looked at very simple workloads, how to invoke them on using Crustlet on Kubernetes, which brings me to the conclusion. So I think Crustlet obviously is better than containers for when it comes to resource utilization. Is that something I have to care about? Well, obviously not from a hosting perspective, because most of my workloads are running in the public cloud, but from monetization perspective, because if I can add more workloads to the same amount of compute power, I can run, or I can leverage, or I can deal or serve to more customers with the same amount of money. So yes, at some point it becomes interesting. I think the benefit is not that huge enough to see the effect for smaller applications. But what I really like about that fact is that we can now fine granularly leverage or provide permissions, or bring permissions to certain service or individual workloads. So basically, it will enhance the overall security and robustness, because I can specify, okay, this workload is able to do X, Y, and Z, whereas the other one isn't. And to be honest, from my point of view, it is still a bit early. And I got that, yes, AKS and Crustlet, I didn't get it up and running. I SSH'd into that node that is actually running Crustlet, and I was not able to spot the error. So it is still early. And right now, my point of view is I would rather go with a virtual machine scale set in Azure, for example, and bring in Crustlet using desired state configuration on my own. But then I have full control over the Crustlet, right? So as I have it on my machine, right? You saw I just fired up that binary, and I was able to integrate that one as a node into my Kubernetes cluster. So if I go that direction, it would be more beneficial when it comes to troubleshooting or actually investigating and seeing what's going on behind the scenes. So that's my take for the current state of Crustlet. I bet it may become not the most popular or not the most prominent runtime in Kubernetes, but it will be place 2. So I don't think that we will get rid of containers all over the place and everything will be WebAssembly. That could be true in a couple of years, perhaps 5 years or in a decade. But as we talk about Kubernetes today, I think WASM will be on the second place, but hopefully at some point feature compliant with containers. And with that, I would say thanks for your attention. And if you have any questions, don't hesitate, just ask. And I saw there was a lot going on it in a chat in the meantime.
We had a very busy chat, yeah.
We had a busy chat and we had a lot of discussions. Before we go into the questions, Thorsten, thank you very much for this super interesting talk. And thank you for taking the time to dive into this early preview. I can imagine how much work it took to put together this demo and to how many hours you spent troubleshooting and all this stuff. Thank you very much for doing that for us. It was a blast watching you doing those demos. I would like to kick it off with one question. I will show it here. It's from Sven, and it's a very good question. And I'm not sure if there is a little bit of a misunderstanding. Sven asks, if a WASM module is converted to an OCI container, why is it that more beneficial than compiling it to a regular native binary and running in a container? I think the misunderstanding is here the conversion to the container thing, isn't it?
Exactly. That's a really good question. So what WASM to OCI does, so OCI is also an open specification that says, okay, you just have to define some fundamental metadata about what you're going to store in that registry. Technically, we're just uploading the WASM module in combination with that metadata. So there is no container for our hello WASM. There's no container for our hello WASI. It's really just that WASM module in combination with metadata, so that the potential consumer, so in my case it was Kubernetes, but I could also ask hey, what is this thing at, what was it, WASM beyond the browser.azure.cr.io/hello wasi.001. What is that? And then the metadata can tell, well, this is an OCI compliant artifact, which is actually a WebAssembly module, right? Mm. So it's more the distribution channel. That's what we are leveraging right here. We're not leveraging containers at any point.
Yeah, very interesting. I think this was a very good question and a good clarification. Stefan, I think this talk was made for you, wasn't it?
Absolutely. So I have a lot to take away from that. And yeah, I guess I have to review the entire talk a couple of times. And try your demo as well. Are you going to share the repo in any case? Cool. That's amazing.
Obviously. I will shoot Rainer a message right after the talk with all the links. So I will put on the slides on speaker deck, and obviously the repo. Where should it be? Where all the repos are, right? It will be on GitHub in a couple of minutes. So yeah, then you guys can share it in Discord and all the channels.
That's nice. I think we can put it into the video description once we put the recording online. I think it would be a good place to put it in the video description there.
Definitely.
Absolutely.
Yeah. Cool.
Awesome. Thorsten, again, thank you very much for taking the time. I hope you enjoyed your time here at the Rust Meetup Linz. And I also hope this was not your last visit here at this meetup. Maybe at one point next year when we do in-person meetup, we would love to welcome you here in person in Linz at one time and have a nice chat, maybe about then Crustlet reaching production level quality. Let's see how it goes on.
Let's see how it goes until there. But I would love to join again next year. As I said, if there is a chance and if everything works out great and we could do in-person things, and that would be amazing. Otherwise, I would be happy to join again for an online session. So let's keep in touch about that one.
Thank you very much.
Right.
Thank you. Enjoy the rest of the evening. Thorsten, we say goodbye. Thank you.
Bye-bye.
Thanks for having me. Bye.
Bye. And Stefan, I would like to hand over to you to welcome our next guest.
So I'm adding, where's my cursor? I'm adding Armin to the stream. So, hey, hello, Armin. Hello. And welcome to Rust Linz. So it was quite a lucky coincidence that you are here today because I was looking for potential speakers for Rust Linz, like for the next 4 or 5 meetups that are coming up. And I also ask you, first of all, because I found out that you are invested in Rust. I also found out that I've been using your open source work for the last decade without me knowing. So I knew about Flask, but Pigments, that's also from you.
Yeah, I also got involved in that. It was mostly the project of Georg Brandl, He and I, we used to have some sort of open source team together called Puku, where we built a lot of open source libraries.
Cool. Great. And you've been involved in Rust for the last couple of years as well?
Yeah, so I'm using Rust since before 1.0. I think, I don't know. So the first time I used Rust, the for loop was based on callbacks, same as in Ruby. So that was long time ago.
Wow, I haven't seen this yet. Cool. And the lucky coincidence is that you said that you are able to join today with, I don't know, a week of notice. So that's fantastic. And I'm really looking forward to what you got in store for us today. So I'd ask the entire chat and everybody watching to put out your clap emojis and give a warm welcome to Armin. Armin, the stage is yours.
Hello. Okay, so I want to talk a little bit about Serde, which is one of my favorite libraries. But before I go to that, I want to explain a little bit about why I'm using this in the first place. So I work for Sentry, which you might know, it's a crash reporting company. And I have secretly introduced Rust into Sentry a long time ago, I think about 2015. When we first started using Python modules extended from Rust code. So we wrote some stuff in Rust and then sort of used it from the rest of the Python ecosystem. And we built there a lot of the ingestion pipeline in Rust. And one of the things that you do a lot there is serializing and deserializing. So evidently we use a lot of Serde. But we also have sort of a problem there because like when we started using Rust, there was maybe not the best ecosystem around for some of the problems that you would typically have, particularly testing. And so one of the things that I wrote specifically to address some problems there is this library called Insta, which is a snapshot testing tool. And it also internally uses Serde. And so some of the stuff that's going on in this talk is it's not directly coming out of Insta, but this is where a lot of this sort of originally took place. So some of the code that now lives in other libraries that I will actually go through in this talk started out really in this Insta library. And so if you're into snapshot testing in Rust, you should look at this because I think it's quite a cool library that you can actually use to do some interesting test cases. Okay, so about Serde. So the talk is called Serde Shenanigans, and it's basically about like using this in ways that's a little bit unorthodox. I also wrote a blog post about this recently, which goes into very much the same, but I want to give a little bit more flavor. So Serde is a serialization, deserialization framework, and it's a little bit similar to, for instance, I'm not sure if it's similar to a lot of systems that exist, but it abstracts away some of the ways in which you reason about serialization, deserialization. And so it exists since around the first time compiler plugins became available in Rust. And so it actually has quite a bit of history, and it's quite flawed, I would say. It's awesome, but there are a lot of restrictions in there, which were okay at the time, but I think by now we have figured out that maybe some of it needs some improvements. But despite all of those limitations, there's actually still a lot you can do. But before I want to go into sort of ways in which you can abuse this, I want to sort of quickly go into how it works at all, if you haven't used it yet. There are two parts. Serde, serialization, deserialization. So let's start with the first one. There are two kind of important traits. The first one is called serialize. And this trait basically defines how a type wants to be serialized. And there's a second trait, which is called serializer, which is basically a trait which is implemented by a thing that knows how to serialize a serialize object. So for instance, a serializer would say, like, I know how to write JSON, I know how to write YAML, whereas serialize knows I know how to instruct the serializer to basically serialize myself. So in this very simple case, you have a point with two members, X and Y, and you can basically implement serialize for point. Serialize is a pretty basic trait. It doesn't have any lifetime to something associated. There's one method on it called serialize, which takes a parameterized serializer and I can do some stuff on it. What's important here, and this is, I think, actually quite clever, is that the serializer moves in, which means that the serializer is moved and consumed in the serialize method, which means that you can actually hold quite a bit of state on the serializer, which then at the end of it, it can move out. So in this case, it's not evident what this does. But I will show an example later of why this is quite valuable. But here you can actually see that the serializer has instructed to serialize a struct called point. It has two members. And what the serializer returns in this case is kind of like a struct serializer substate object, which you then can say like, hey, I want a field serialized, another field serialized, and then I want to end the whole thing where I am. And the end method then returns the end result that the serializer thinks should be returned. Most serializers don't return anything, so they will return void. But you can actually have the serializer return some interesting data. And we'll take advantage of this later. Because nobody really wants to write code like this, there's automatic support to automatically deriving this. This pretty much generates the same thing as before. But there's actually quite a bit of stuff you can do on this sort of automatic deriving system to customize this a little bit. So I already mentioned that consuming serialize is a really useful property. And the reason this is a useful property is because you don't have to produce bytes. A lot of serializers will produce bytes. In particular, everything that sort of is a wire format like YAML, JSON, even bin code, they will typically take a writer as sort of the input to the serializer, and the serializer will hold the writer, and then every serialize method will just write into the writer. But you can also do more interesting things. So here, for instance, this is straight out of originally Insta, but this is also what I use in Mini-Ginger, which is a serializer. It's called a value serializer. And it actually produces an object. So instead of serializing into bytes, it returns a new value. In this case, it's like a value type. It's not called value. It's just an enum of a bunch of different variants. In this case, you can see like if it tries to serialize an I64, it actually returns a value that has an internal representation of I64. Now, why is this useful? Well, it's useful because it can transform serializable things into different things. So for instance, I don't want to like go too much into this because it's kind of hard to see. But here you can basically see like this is still the same serializer from a value serializer. And when it wants to serialize a struct, so a type comes around and says like, hey, I'm a struct, like I'm the point with two X and Y coordinates. The serializer here will actually return a serialized struct, which is sort of the internal sort of abstraction to how to serialize a struct. And again, it moves. Well, first it will produce this. So it will say like, hey, I want to collect a bunch of fields into this. And so then the serialized struct implementation, which is this one here, whenever a serialized field is invoked, which is what we used earlier. So you will see this here. Right, so serialized struct returns the state. The state is actually this thing that we have over there. And then serialized field is being invoked, right? And so this is what we have here. So we actually say like, okay, I want to store the key. And then the value, which is again serializable, we will again go back into the value serialize and sort of effectively descend into like recursively into the next kind of thing. And then we end this by producing a new value, which is now represented as a struct of all the fields. Right, so this is basically an example of how a serializer doesn't actually have to create bytes. It can actually create a whole bunch of other interesting things. The next part after this is, and what's important to notice here again is because this consumes, so the end of the end method on this consumes, it means that you can move out the fields from the serialized struct helper. If it wouldn't be able to consume, it would just be end mut self. You would have to do some other stuff like maybe move out of an option, but this is quite convenient this way. Deserialization is a lot more complicated for two reasons. The first one is that the different formats in 30. So I think everybody can quickly understand how serializing works. It's just you recurse through a structure and you just write some stuff. But on deserialization, there are different types in which you can deserialize. There are formats that are like JSON, where it's pretty clear what's coming your way. But then there are formats that are what's called non-self-describing. So these are formats that don't tell you what data is coming. You already have to know ahead of time what you get to expect. And that because of this, 30 has two different ways to deserialize. I just want to go into the first one, which is the one that involves self-describing inputs. So a self-describing format is basically a deserializer that whenever it parses a token, can determine from the token what it is. Like in JSON, for instance, if a string, if they're double quotes, then you know it's going to be a string. If it starts with the number, then you know it's going to be a number. It's going to be an integer or it's going to be a float. And the way this is implemented in 30 is that you basically create this visitor, and then you implement all the visit methods which you want to support. So in this case, we have a Unix timestamp type. And we implement two variants to it. The first one is a U64 variant. So if the deserializer is invoked with U64, it will directly create a timestamp. If it's passed string from the deserializer, then it will try to parse it with the chrono datetime parsing function. And then again do the same. And sort of the trick here is this deserialize any at the end. This basically means deserializer, please give me one sort of token and then pass this to the visitor. But the challenge here is that not every single format actually supports this. And I'll show you a little bit later why this is a problem. But basically this means that this deserializer only works with JSON data, for instance, or YAML. But it wouldn't work with bin code, for instance. Why? Because then you have to already tell the deserializer what you're going to expect. Like, for instance, I know it's going to be integers. So you have to tell it, I want to deserialize an integer. I don't want to deserialize whatever comes next. The second sort of more complicated part here is that lifetimes are involved. So one of the things you can do, and not a lot of people do this because it's complicated, is that you can deserialize and you can borrow out of the deserializer's input. So if you think, for instance, JSON, a lot of strings don't involve unescaping. And if strings don't involve unescaping, you could basically take a slice of memory of where the input string is, and you can sort of borrow out of this without having to clone the string. That's what this lifetime is for. And for some formats like bin code, it's actually relatively useful. But in a lot of other cases, it's very hard to support because the input format doesn't support it. The pretty obvious thing is that the deserializer can only ever produce one output type, which is itself. So the deserialized trait can only ever output itself. So in this case, the visitor can only produce this one too. As mentioned earlier, deserialize any is not always supported. This is what the three different types of formats look like that 30 can roughly work with. So the first is what's called a self-describing and human readable format. Both of those concepts are called this way in 30. I don't know if they're generally terms that are used. Self-describing means you can take an input like a JSON document, and even without knowing anything about the schema, you can make sense of it. Human readable means that, well, it's more or less ASCII kind of thing. The second example, this is message pack, which is also self-describing. So you can translate this to JSON and back, and it will more or less look the same. But it's not human readable because it obviously involves a bunch of binary stuff. And the last one, which is probably not as easy to see, is that this is a non-self-describing format. And this is sort of a packed binary representation where you have to know that the first thing you're going to decode is key 1, And so the only thing that the format tells you is like, okay, the next 5 bytes are value, which is sort of the value to key 1. And then the next 5 bytes, again, are, in this case, actually, this format kind of assumes that this is a tuple of 2 items. So it says, again, there's going to be a string of 5 bytes called value, and then there's going to be the 1 byte value number 2. And obviously here, the problem is that if you don't know what you're decoding, then you can't make any sense of it. So you have to understand the schema so that you can parse this. And the deserializer support in SERDI can support all of those cases. What we're going to look at in this talk is actually only going to be self-describing. Non-self-describing formats in SERDI are supported well by SERDI, but they're not supported well by the ecosystem. This has also quite a bit to do with buffering. When you, for instance, take JSON, you have no guarantee in which order the keys are coming in. So there's no guarantee that key 1 comes before key 2. So for a deserializer, it's actually better to just parse the whole thing and then rearrange these keys to sort of what's expected, rather than to assume that the first value is going to come in is going to be key 1. And for a non-self-describing format, you can actually assume perfect ordering. Okay, so that's the boring part. Let's see what we can actually do with this. So I have 2 things I want to show. The first one, and both of them are related to sort of libraries I wrote, but I wasn't the first one sort of discover this or use this. So the first thing is you can use SERDI to implement runtime type systems. This is what I use this for. I have a Rust re-implementation of my Jinja template engine. It doesn't do everything that the Python version does, but it comes relatively close, I would say. And it's called Mini Jinja because it only has SERDI as a dependency. So everything else is entirely optional. So this is what this looks like. Effectively, this is the API, what it looks like. So you create this environment object. And then you parse and compile a template by adding it to this environment. And then when you call this context method, the context macro, you're basically creating like an object on the spot here, which is just a SERDI serializable object, which basically says like there's a key called name and there's a value called John. And then it invokes render. And what's important is that I don't have to have the name John. I could have a complex object for as long as I can serialize. And then basically going to pass this in sort of the template engine. And then in the template engine, it's like a programming language. You can do stuff with it. You can add numbers, you can call methods, you can change it, convert it between types, everything that you would expect. And so basically, for this templating engine, internally, there has to be a runtime representation of the values because like until you run this, you don't know what's in there. And for this to work, I'm basically using SERDI. Internally, in the evaluator, this has nothing to do with SERDI, but I think it's important to understand. In the evaluator, you have basically a bytecode interpreter. And so every instruction is a bytecode instruction. And based on that, it does something. And what you can see here, store local is, for instance, the instruction to store the top of the stack in a variable of a specific name. So in this case, it pops, for store local, it pops the top value from the stack, so the stack machine, and then it stores it in the local variable called name. For lookup, it does the inverse. It tries to look up a variable with a specific name in the current context, and then if it doesn't find it, it returns undefined. And then get Adword is kind of similar. You take the top value from the stack, and then you look up an attribute with a specific name. And as you can see, value.getAdword is sort of a method that exists on the value trait, on the value type, so that you can actually do dynamic lookup. So how does this work in the engine? So this is an example from Jinja template. So you have a for loop. So it goes for every user in the list of users. It wants to render this. And the interesting part here is actually, I don't know if anyone is familiar with the Jinja templating engine, but Jinja gives it a secret variable called loop. And loop refers to the loop itself. So as you're iterating over your sequence or your iterable, behind the scenes, the loop also exists, and it gives you access to, for instance, the current index of the iteration, or it gives you access to the length of the iterator. And one of the things that Ginger also always provided was this loop, the cycle method. And this is also what I implemented here. So on the loop context, there's a cycle method, and you can give it multiple parameters. And so on first iteration, it will return odd. On second iteration, it will return even. On the third iteration, it will return odd. So it basically just takes this input, and it does modulo loop index. So what does this have to do with SERDI? Well, what it has to do with SERDI is that this loop object has to exist in this runtime type system that we have. So the input to the engine is a bunch of SERDI compatible types. So what are SERDI compatible types? Integers, strings, lists, structs, options, but that's pretty much it. Tuples too. But for instance, SERDI doesn't have a concept of, well, file handles. SERDI doesn't have a concept of arbitrary Rust objects. So what doesn't exist in a SERDI type system cannot go through a serializer. So a serializer can only visit into the structure of something. So if you, for instance, take the loop, so the loop has state on it like index, length, and so forth, but you cannot serialize the loop. You could only serialize the current state of the loop, but you can't pass the loop through serialize, deserialize. But this is actually what's necessary for this system here to work in the templating engine a little bit. I will explain why later. But the second part that's kind of more obvious is that this is a method on it, right? So how does this work? Internally in the engine, it's again the same. There's a method on it like get Adword. There's a method on it called call method. And so you can call a method on a value. This is what happens if you enter the loop. And I think this sort of starts going a little bit into what the problem is. When the engine starts executing a loop, so it enters the loop, it pushes the current loop context on top of the stack. And the only thing that we care about here is actually this loop state. So loop state is this loop variable. So we have the current index on it and the current length of the iteration. And as you can see, we wrap it in an arc, so an atomic reference counted wrapper. And actually, there's already sort of a curious part. You cannot, out of the box, serialize a loop controller in SERDI, even if loop state is serializable, because arc is not serializable out of the box usually. You can make SERDI serialize arcs, but we don't care about this right now. It will work for us. But what you can see here is that we're wrapping this loop state, and we're saying like one reference here actually goes onto this frame, and then later we can actually sort of hold on to this reference in other places too, which we will do. So loop state then refers to what this loop variable was earlier, and I can show you how this happens, but it's not so important. What's more important is that we have a custom trait in Miniginger called object, and this object is used by anything that's sort of dynamic. And so object is obviously implemented for loop state, and one of the things that it has is a call method callback, which is what we called earlier. And so like, okay, I want the name of a method, and then the arguments passed to that method. And every argument is, again, this value object. So value is really just this runtime type object that we're using everywhere, which is serializable. And so if we're trying to call the cycle method and we're loading the current index, we're looking up in the argument list index modulo argument length. So we're basically cycling through. And then we return this argument cloned. So value is clonable. Why is value clonable? Well, because everything in there is reference counted. So values can be relatively cheaply copied. So this is roughly what this looks like, right? So when the engine goes, say, loop dots, if the user goes loop.cycle, via some sort of indirection, it calls into this here, and it will do whatever is done here. If you try to call any other method on it, you're going to end up in the second branch, which tells you there's no method named this. So value is basically a reference counted object that utilizes interior mutability. And more importantly, it can hold data that someone else also modifies at the same time, right? So in the sort of where the user interacts with the template engine, there's this loop object and a bunch of other stuff. But while this is happening, the engine itself holds also on to the loop context to do some modification. So when you, for instance, iterate, so if the engine wants to iterate one step forward, then it increments the index of the loop controller by 1. It fetches the next item from the iterator. It pushes the item on the stack. And if it reached the end, it will actually just jump to the exit condition of the loop. So the controller here is modified by the engine. At the same time, someone else can hold on to the controller. So you can, for instance, imagine that someone would reassign the loop variable to another variable in the engine. So then you have like 2 pointers to the same loop controller. Sort of 2 handles to the same loop controller. So interior mutability is happening over there. So, but what does this have to do with serialization? And how do you actually serialize the loop controller? So value has to be serializable. Why does it have to be serializable? Because I might pass out the value from the sort of template engine into some other callback context. And someone might want to then again pass this to another template. And then it has to go into the serialization system again. So how can it pass through these internal abstractions if SERDI doesn't allow me to pass data through that doesn't follow its own object model, right? So if you can imagine, I could take my loop context and I serialize it into index and length, but then the internal template just sees a dictionary of index and length. It doesn't see a loop controller anymore. So if that template, for instance, through inheritance or something like this, wants to modify or interact with the loop, it will not find these methods anymore. So the answer to this is very ugly. It involves thread local storage and in-band signaling. So this is how this works, and this is why it's kind of ugly. But unfortunately, there's no significantly better way in SERDI today, but it kind of works. Basically, we use a combination of thread local storage and in-band signaling to communicate non-SERDI data outside of the main SERDI sort of communication format from serialized to serializer. What we do is there's a special internal reserved string, which starts with some binary, which says like, if you see this around later, this doesn't refer to what it would refer to normally. And then we keep some thread locals. The first thread local that we hold is just a bool that says, are we serializing internally? If this is false, then it means someone is serializing my value to JSON, for instance. If this is true, then we are serializing for Miniginger itself. So when Miniginger tries to serialize for its own uses, it will flip this to true. So this means that any code that serializes can decide if it wants to serialize for JSON, where it would serialize the loop context as you would expect as an object, or if it wants to serialize for Miniginger, where it wants to keep the original value and just bump the reference count. Then we have a last value handle, which is just a counter that goes up into infinity. And then we have a stashing area where we associate every handle with the value that it points to. And then we just have a helper function to figure out if we're internally serializing. So this is the marker. This is where the values are stashed. And these two things are the most important ones. So when we serialize a value, so this is serialized implemented for value itself. If you are in internal serialization, so that means Miniginger wants to serialize data for itself, we get a new handle by just incrementing the count on this TLS. Then we stash onto that handle ID a clone of ourselves. Then we serialize a struct named value handle marker. That was this sort of weird binary one under Miniginger under value handle. And then we serialize a single field called handle, and then we end the whole thing. So we basically compress our handle ID into a little bit of structure that is then internally referenced by the code. One second. Okay. So it's serialized for itself. On deserializing, we then need to figure this out again, right? So this is where it ends up in this value handles. And then on the way back in the deserializer, or it's not in the deserializer, in sort of the struct serializer, we basically, whenever we then find in our own serializer, whenever we find structs, so when we collect these structs as we did earlier, we actually now look if the struct name is our value handle marker. And if it's the value handle marker, we take the handle field of that struct, extract the handle ID out of it, and then look in the TLS if we're in there. And this sort of really bizarre dance that we're doing here lets us pass through the original value unchanged through multiple layers of serialize, deserialize in the engine. So why do we do all of this? So one example for this is we need first-class functions in Minichanger to support what Ginger is actually doing. So this is valid Ginger and Minichanger code where you say like, okay, I have a function called cycler, which returns an object which is callable, and whenever you call it, it returns the next value. So first it will return odd, then it will return even, and return odd, even, and so forth. And for this function to exist in the runtime, it has to be serializable. And so this is what this looks like. We have a function called makeCycler, which returns a value from this object, right? And so if you look at value from object, this creates a value that internally holds onto the cycler, which has to be has to implement object. And then I can stash it into the global scope with env add function. And this basically just does nothing else but boxing the function and storing it. And the funny thing with this is that from the engine's perspective, I have now the ability to store any artificial additional data in it, and I can go through any layer of indirection in SERDI without having to build my own object system on top. So for instance, I'm using this not only to hold onto dynamic objects and functions. In Minichanger, I also hold onto special types of strings that are exactly like strings, but have additional meta information so that I can do something useful with it. So for instance, in a lot of template engines, including Ginger, there's a difference between a string and a string that has already been HTML escaped. Because if a string is already HTML escaped, then I don't have to HTML escape it again. And so I have sort of two string types internally, even though the original SERDI can only have one single string type. The sort of idea of using in-band signaling is actually something that even SERDI itself uses. So the SERDI JSON support has support for arbitrary precision integers. So integers that are significantly bigger than 128. And it uses exactly the same system internally to stash large strings as large numbers. And it also uses this ugly in-band signaling. So ideally, there would be a better way to do this. But you can kind of do this anyways by using TLS. It's ugly, but it works. But it only works for as long as your serialize and your serializer cooperate. So if you were to serialize a value, not to serialize internal. So if you were to serialize a value object, not to Minichanger's internal serializer, but for instance to YAML or to JSON, then none of this would work, right? Because like it wouldn't know how to grab this stuff from TLS. So we would actually leak this out if we were to go through this code path. And this is why we have to figure out, do we serialize to Minichanger or do we serialize to something else? Another kind of interesting thing you can do with this is sort of this idea of IPC auxiliary data. So with this little crate sort of experimental, it's called Unix Ipc, and it lets you pass data from one process to another. And what's kind of odd about Unix Ipc is that Unix lets you send bytes through a socket, but if you send between processes, you can attach extra data on the side, which are file handles. So you can, for instance, pass a file or a socket from one process to another process. And it's all well and good, but unfortunately, with a higher level abstraction, it can become really unwieldy to do this. So you can, for instance, imagine that you might have a description of a task that you want to do. And this task involves like some input data. And you want to pass this input data to another process. But sometimes you also have to pass really large things like sockets that you don't want to reopen in the subprocess. So for instance, when you implement something like a web server, the socket is already open. So now you want to pass the socket to a subprocess, so the subprocess can, when it's done with its stuff, just directly send the data to the socket. And so I was playing with this idea of making abstraction over SERDI to send file handles between processes. So how do you pass this? I don't know if you're familiar with Unix Ipc, but there's a call called send-msg, which as a first argument basically takes the bytes, and a second argument takes its ancillary data. And so my idea was you can write a SERDI abstraction where a SERDI doesn't just produce data, it also collects file pointers. And so this is what I wanted to do. So I wanted that you can derive serialize and deserialize on a struct, which is, for instance, task. And in this case, the first argument, the first field on the task is a TCP stream. But because TCP stream obviously is not serializable, I have to wrap it in a new type, which is called handle. And this makes anything that has a Unix file descriptor serializable. And the second thing is like a task payload. And so this is what I want to do is I want my subprocess, I want to connect to my parent process, create a receiver, and I want to receive one handle, as I saw in this case, actually task. So it should not be let handle, it should be let task. So I receive one task, then I want to compute the result on the task payload, and I want to send the result directly into the socket that I also received on the task. Right? That's sort of the goal that I want to do. So basic goal idea is figure out a way to serialize and deserialize the task, but whenever you encounter file handle, just put it somewhere else. So this is how serialize is implemented for handle and handle ref. Handle ref is basically an internal thing that's almost like handle, but it works slightly different. It has to do with one consumes the file descriptor and the other one just holds a reference to it. So in this case, when it serializes, it checks, am I in IPC mode? This is again the same logic as I did in Miniginger. There's a thread local variable that says true if we're serializing for IPC and false otherwise. So if we're in IPC mode, then we take the file descriptor, which is on ourselves. We register the file descriptor on a thread local variable. We serialize the integer of no longer the file descriptor, but the index in our FD array with the serializer. So originally, you, for instance, had like, say, FD45 in there, which was the socket. Now it serializes 0 and puts FD45 into an array in TLS. So it stashes away in TLS. And then on the way back, this is the deserialize for, in this case, well, I didn't actually put the deserialize in here, unfortunately. So, but the deserialize basically does the same. It deserializes an integer, and then it does lookup FD to find the FD in TLS again, and then get it out from there. And this is what this looks like if you send it, for instance. So on sending, it serializes my original input, the task, for instance, into bytes. And instead of getting just out bytes like you would do in SERDI normally, you get out the payload and the file descriptors independently. I'm actually not sure where my slide went that has this in there, but what you can imagine how this looks like is that I stash away an empty vector on TLS. I'm putting my my file descriptors into this array every time I'm encountering a handle. And then at the end of it, I just pick them up and serialize, and then I can send them independently as payload first argument and FDs a second argument. And that's all there is to it. So I know this is a lot, but you can find some of the code that drives this on my GitHub. And there's also a blog post that goes with it on my blog, which is linked here, which explains this a little bit more in detail. I think what's interesting about using SERDI like this is that because SERDI is so universally used all over the place, there's actually quite a bit you can leverage with it, even if it's really sort of out of the ordinary. You have to imagine that there's almost every single type in Rust is serializable. And so there's a big ecosystem that you can use. If I were, for instance, to want to write a template engine, where in order to use an object in the template engine, you would have to implement my own trait, then I couldn't leverage a lot of the traits and a lot of the objects in the ecosystem. But because almost everything is already compatible, I can basically build on top of that. Okay. So I can go to the questions probably, unless there are some other things.
Armin, thank you very much for this great talk. Stefan is joining us too.
I'm back, yeah. And what I've seen from the chat, there have been a lot of mind-blown emojis. So wow, that was fun. That was interesting. I guess we have a couple of questions in.
Yeah, indeed,
we have YouTube chat.
We have some. I have one here on the tip of my fingers here. Let me bring it up. Lucas is asking whether you could elaborate a little bit more why you think that consuming the serializer, I think you have shown that in one of your slides, is so beneficial. Could you elaborate a little bit more about your thoughts in this direction?
Yeah. So the really beneficial part of the serializer being consumable means that you can use effectively any method when you finish serializing. So the counter example of a trait which doesn't work like this is drop, for instance. So if you've ever implemented drop for a type in Rust, you've found out that it uses end-mut instead of consuming self. And the downside of this is, for instance, that you can no longer call anything on it that actually consumes. So quite often in Rust, you're faced in a situation where if you're not in a method that can consume, that you can, for instance, no longer move out of the struct, right? So you would have to wrap everything in an option so that it can move, it can take out of the option. And this makes the code a lot cleaner because if you're writing more interesting sort of the not serializing into bytes, but into something else, a very common thing is you collect, and at the end you want to take all these things to convert it into something else. And if you couldn't move, you would have to drain a vector, or you would have to take out of an option, do things like this. And in this case, you have the full opportunity to do whatever you want with it.
Thank you very much. Thank you. So, Stefan, did you have a quick look at the next questions?
There's one more from Lucas that I want to add to the stream, which is what's the difference between thread local and lazy static?
I saw that.
Is lazy static the process equivalent of thread local? I assume that's
basically the process equivalent of thread local, but in practice, because of Rust's boring model, they actually work completely different. So a thread local, you can never read directly. The only way in which you can read it is in a callback. So I have an example here. So here it says value handles.with. And so you cannot read value handles. So value handles is a thread local, but you can't read it directly. The only way in which you can read it is by calling .with on it, which will invoke a callback. And then that gives you, for the duration of that callback, gives you the thread local, which is typically read-only. And then you have to use interior mutability, like I'm using here, to borrow it mutably to do something with it. And lazy static is basically like a global constant that, because it lives for the duration of the process and has static lifetime, you can handle like any other variable. Whereas, due to how threads work, and threads can die at any point in time, you have to do it callback based. Because you could imagine otherwise the thread would die for whatever reason, and you took a reference to this thread local and you try to do something with it, and then you would sort of end up in undefined memory, which is not what you want.
Mm-hmm. Cool. Right.
Interesting. I have to say that you changed my view on serialization and deserialization quite a bit. I've never thought about Serde in that way. For me, it was always this thing where I shove in some stuff and out comes JSON or something like this. But now I have a different view on it. So thank you very much. Thank you very much for opening this perspective.
There was actually, let me see if I can do this here. Because like one of the things that already triggered this originally was this thing here. So if you, let me see if I can bring this here. So if you look into documentation, for instance, of how Insta works, you can basically do this sort of assertions. Let's see if this might be. Right, so Insta is based on this idea that you do this like assert snapshot, and it serializes this input here, and then because it serializes the input into a file, then you can next test run, you can compare it, right? So this is the idea. It's like if you have a lot of output that changes all the time, you sort of take these snapshots and you run the test again, If you, for whatever reason, change your test or the algorithm or whatever, you can review the snapshots quickly. Sort of this is this idea. So you see like old snapshot, new snapshot. But the problem, and this is what started this whole adventure of trying to do something interesting with Serde, is that if your tests contain data that is not stable, like for instance, imagine you're writing into a database all the time, but the database ID is changing constantly. Then every time you go through this, your snapshots fail because they are like wrong, right? And so this was the first sort of experience I made with this, where I was trying to intercept Serde as it was doing stuff so that I can like select segments of stuff to modify it. So for instance, if you have the user and the user ID changes all the time, I have the selectors, like whenever you counter.id, replace it with something else. And this is the way this is implemented. It sort of sits in between Serde and another Serde serializer, so that you sort of modify what it does. And it's shockingly powerful, Serde, even though it has so many limitations. You can actually do quite a bit with this.
Cool. Interesting. I have to also take a look at Insta, because I think I have quite a bit of use cases for this. I wasn't aware that it exists, but now, yeah, absolutely, it absolutely makes sense. Personally, my first, I got a first glimpse into what Serde could be when I was looking at WASM and WASM bind, and there are also different ways of doing JSON serialization between, or passing JSON values between JavaScript and Rust. And I read about the two ways of, on the one hand side, really serializing it into JSON, but there is another kind of serializer where Serde is, I think, value by value, directly grabbing the value from JavaScript without going through text. And there, yeah, I had the feeling that Serde is more than just a JSON in, a JSON out. And your talk reminded me a lot on that first idea, but I haven't taken a look at it.
Yeah, there's a lot you can do with it. It's quite fun.
All right. So I had another look at the comments, but I think so. So Lucas had one more comment, which was a summary of what we've just seen, I say yes, Lucas, you're right. I guess that was it. But other than that, I guess we don't have any more questions. So thank you again, Armin, for being here on such a short notice, for giving this amazing talk. That's again one of the talks that I'm going to have to look up a couple of times. There's so much stuff in there that I need to review again. So that's fantastic. So yeah. Thank you for being here. Thank you for sharing your insights with us. And I'd say, so for everybody still in the chat, get your clap emoji out once again and give a round of YouTube chat applause for Armin.
Thank you.
Bye-bye. Thank you very much. Thank you, Armin. Stefan, I think we are done for today. We had two very interesting talks. I hope everybody in the chat, in YouTube and in Discord enjoyed today's meetup. I'm looking forward to next month, And yeah, if you want to stay in touch with us, again, use Discord, join us there. Any final words from your side?
Yeah, follow us on Twitter @RustLinz. We are going to announce new dates and speakers, etc. all there. We also retweet your stuff. So if you have anything that you want to share with us or with our community, ping us. We are retweeting it. So that's for sure. We aim the next meetup to be around at December 16. Yeah. And we also have one lined up for January 20. So we already have a speaker for the January meetup. I'm not going to spoil it to you right now. You're going to get to know it next time. But yeah, so there's a couple of stuff going on. And with that, I want to wish you a nice evening. Enjoy your Lieferanto pizzas. And a nice Friday, a nice weekend. See you around. Bye-bye.
See you. Goodbye. Have a nice evening. Bye.